Today we're going to experiment and try out a few different procedures for making carbon monoxide gas. Carbon dioxide you all know about. It's the gas you breathe out, and the gas you get when you mix a carbonate salt with an acid. But that's not what we're dealing with here. Carbon monoxide has the formula CO and it's very different stuff. So a quick warning. Carbon monoxide is deadly. We will explain why later, but the problem with it is that it's colorless, odorless, tasteless, and you can't tell it's there. And it doesn't take much to give you permanent brain damage, or even kill you. We'll try out the 3 methods on a test scale first and see what happens. Our first method involves the dehydration of formic acid. Here's the formula. You can see that if you remove water from this, you end up with just a carbon and an oxygen atom left. Carbon monoxide. What we've got here is about 10 mL of 85% formic acid, which is the strongest commonly commercially available acid you can get. It gives off pretty pungent acrid fumes, so it's not too pleasant. You can see here that it's also quite volatile and there are acid fumes coming off. It will also give you very painful burns, so take great care. Okay, let's first transfer the formic acid into a larger beaker. And here's our dehydrating agent. Concentrated 98% sulfuric acid. We're not too sure how much we'll need, so we've got about 40 mL in a conical flask and a dropper so we can slowly add it. As you may know, sulfuric acid has a great affinity for water, and so is excellent at decomposing organic compounds by sucking out the water. This also goes for your skin though, so wear gloves when handling. Okay, let's see what happens when we add the acid. Slowly we've got a little reaction starting up, and some effervescence. Not much though. Let's add some more acid. Going a bit faster now. In fact, the reaction speed seems to be both a combination of the amount of acid and also the temperature. Adding more acid also increases the temperature, and so the reaction speeds up. Now we've got a pretty vigorous evolution of a colorless gas. But what is it? Well, one easy test is to see if it burns. Carbon dioxide isn't, whereas carbon monoxide is highly inflammable. Okay, that looked like a quick flame from the beaker. Let's get the lights out to see it better. Let's get a bit more gas. That blue-colored flame is characteristic of carbon monoxide, so this method works well. Okay, let's try method number 2. This time we're going to do a similar dehydration reaction, but instead of using formic acid, we're going to be using anhydrous oxalic acid crystals, as you can see here. Here's the formula. Again, you can see that it's possible to remove water, but the reaction isn't so simple. We're going to end up with a mixture of products, both oxides of carbon being produced. Carbon monoxide and carbon dioxide. And we're going to use sulfuric acid again as the dehydrating agent. So let's see what happens. Well, nothing immediately. The acid crystals are quite wet with concentrated sulfuric acid, but there's no obvious reaction taking place. We'll add a bit more acid. Still no reaction. So what we'll do now is we'll set up a hot plate, and we'll see if heating the mixture has any effect. While we're warming, let's look at why carbon monoxide is so poisonous. Your blood contains red blood cells, and within these is a protein called hemoglobin. It's an extremely complex protein with a molecular weight of over 60,000. So we're not going to try to draw it. But what is important is that contained within this protein structure are iron atoms. And it's these atoms which are able to bind oxygen and transport it around your body. And of course, the oxygen is needed for your cells to produce energy. But carbon monoxide happens to be a big fan of these iron atoms, and if it finds one it binds to it preferentially, blocking it from carrying oxygen. Without oxygen your brain and heart will quickly shut down and fail. You'll get sleepy, unconscious, and then die. So take no chances. This is a dangerous substance. We've been heating now for a while and it looks as though there's a few bubbles forming. Let's just add a bit more acid to try to get this to happen. Pretty soon it looks as though the oxalic acid has dissolved. And at this point, with a bit more heating, we start to get some foam appearing on the surface of the mixture. So it looks now as though we've got the reaction starting to occur. Any chance of the carbon monoxide igniting this time? No, it doesn't work. Perhaps not enough is being produced, or perhaps the carbon dioxide also released by the reaction stops the burning from happening. Okay, well, this method is producing some gas, but we need to absorb the carbon dioxide if we wanted to get pure monoxide out of this. The reaction is also slow and tends to foam, as you can see, so it's not so convenient. So finally, let's move on to method 3. This time we're going to do another decomposition reaction using sulfuric acid, but this time we're going to use a small amount of anhydrous potassium ferrocyanide powder. Remember at this point that we're using concentrated 98% sulfuric acid. If you use dilute sulfuric acid, then you will get a reaction producing a deep blue mass and hydrogen cyanide gas evolved, which as you know is a deadly and rapid-acting poison. So don't even think about it. Okay, let's add some sulfuric acid to the anhydrous salt. Some initial white smoke, but then nothing. There's no apparent reaction at all. Let's get some more acid in and then mix thoroughly. And now let's heat slowly and see what happens. The mixture stays yellow for a while, but then after a bit more heating there's a slight pink color, and then the color fades to a gray. But no sign of any gas coming off. A tiny amount of what seems to be wispy smoke. Even on very strong heating, there's something coming off, but it's very slow indeed. So this reaction might work in theory, but in practice it's no use as a preparation method. Okay, so we found the method that works. Formic and sulfuric acids. Let's set up a slightly more controlled version of the apparatus now. Here we go. Just a quick tour We've got the 500 ml 2-neck flask set up. This is way more volume than we need, but we wanted to be careful just in case the mixture foamed. The main neck we'll use to add the acids, and then the side neck connects to an adapter and hose. And this leads into a glass tube which we can use to bubble the gas through a liquid. On the left we've got some 98% sulfuric acid, around 30 ml. And on the right some more 85% formic acid, around 20 ml. We'll do this as before and add the formic acid to the flask first up. Okay, so now we're ready for action. All we need to do is add the sulfuric acid. We've got our tube leading into water to start with, just so we can see how much gas is produced. So the million-dollar question: what are we going to do with our carbon monoxide? Well, let's show you what we've got. Here's about 10 ml of the juices obtained from unwrapping a large vacuum-packed piece of steak. You can't think of it as a blood substitute. But although it's red and looks like blood, it's not. Red meat muscles contain myoglobin, another oxygen-carrying protein which is similar to hemoglobin. When the meat is cut and it rests, some water and myoglobin seep out of the meat. Note the color is actually much paler than blood. So next time you hear someone complain about their steak being undercooked and containing blood, you will know they are full of shit. But myoglobin also contains iron atoms to bind oxygen, and just like hemoglobin in blood, carbon monoxide will bind preferentially. So let's try it out. Here's some sulfuric acid. Look closely, you can see the color change. It's turning a darker, more cherry red color. See the difference in the color? You can compare better if we put a few drops of the myoglobin containing meat juices onto some tissue paper, showing the before and after treatment. Although it's not a perfect substitute for blood, it does demonstrate in exactly the same way why carbon monoxide is poisonous. And one of the characteristic symptoms of poisoning is said to be that your skin and lips turn a deep intense cherry red color. So our advice is go and buy a detector for your household. Just do it. They're small and cheap. Too many terrible tragedies occur every year from faulty boilers or gas burners. The bad news for chemists though is that under normal lab conditions, carbon monoxide isn't very useful. You can't really perform simple or easy reactions with it, apart from just burning it and seeing the blue flame. Better just to watch the video. Stay tuned.